All right, a lot of people have had problems with number 10. We did it in both classes. It's on page 365. And one of the problems people are having is they're not sure what the difference between S and T are. S and T are just like X and Y. Just like in the alphabet, X comes before Y, S becomes before T. So that's how that works. It's a similar process, it's just using different variables. S plus T equals -4. In this case, we're going to solve it by substitution. And what we're going to first do over here, S minus T equals 2, we add T on both sides. And why do we do that? Because then we get S equals T plus 2. That's something we're going to then substitute into there, in for S, right here, okay? We're going to put it in there. And then this equation will now become T plus 2, we'll put that in brackets, plus T. So that's how that works. With the substitution, then we get 2T plus 2 equals -4. Subtract 2 on both sides, 2T equals -6, divide by 2T equals -3. Once we have one, we can get the other one. Now remember, you're always looking for a solution, and solutions are points. That means they have both an X and Y coordinate. In this case, S and T coordinates. We've got one of them. We got the T coordinate. We plug that back into this one, which is S equals T plus 2, and we get -3 plus 2, so S equals -1, and we've got our solution, -1, -3. That's a point on a graph. This question in this example didn't ask you to graph it, but we did it anyway, just for fun. So here we go. We're going to show you what we got with the graph. I mean, you can see it there, but let's show what we did. It's no different than y equals mx plus b. The only difference is now we don't have y and x, so we call it T equals ms plus b, right here. Instead of y equals mx plus b, we now have T equals ms plus b. So in a similar way, we just go ahead, we had S plus T equals -4. I'm going to draw that over here. S plus T equals -4. We solve for T, so we subtract S on both sides. We get T equals -S minus 4. And now it's in the form we want, T equals ms plus b. We can find the slope as -1, and the y-intercept's -4, which we then graph over here. But we'll get to that in a minute. We'll go back over and get the second equation, was S minus T equals 2. S minus T equals 2. We have to subtract S on both sides. We get -T equals -S plus 2. We divide by -1 to make sure that T is positive. And we get T equals 1S minus 2, or S minus 2. The slope is therefore 1, which is 1 over 1. And the y-intercept is -2. Now we take the information we got. I'll box them both. This is the valuable information. The slope here is -1 and the y-intercept is -4. So we start at -4. We start at -4 because that's the y-intercept, and we go down 1 over 1. Down 1 over 1 right there. And that gives us our second point and then our line. All right? This line here is S plus T equals -4. That's the equation of that line. This one right here has a slope of 1 and y-intercept -2, so we start at -2 and then we go rise up and run over. 1 up, 1 over, and that's our second point. This is our line. I'll draw it in blue. It is the line S minus T equals 2. S minus T equals 2. Those are the two lines. What are we looking for? The point of intersection, the place where they come together. Right there, where two characters meet. Yeah. The climax of a play. Right there. That's where they go, and then they go off in their own direction. That's the solution. Whether you look at it graphically or whether you discover it by substitution, it's the same thing. -1, -3 is our approximation, and guess what? That's what it is. Right there. Boom. Boom. Shakalaka. There we go. What's wrong with it? Boom shakalaka. Rachel, come on up here and do that.
Don't do it.
Rachel.
Wait. Me and Jessica.
No, I want to be in there.
Everybody loud, please. Loud. 1, 2, 3.
You gotta sing it.
It's really tiny.
Okay, right here.
1, 2, 3. And
African dancing.
I was going the wrong way.